And then we've got on message. When a connection sends a message to the server, what do we do? So in this case, what we're going to do is loop through every single one of the clients that's connected and say, if the message is not, if the client we're currently looking at is not the client from whom the message came, then to that client, send the message. So this stops user 1 getting his own messages. So this one line here, that's the logging. So I could take that out and stop the logging. We're no longer reliant on logging being a mechanism for providing the messages back. It's all in real time. If you took that out, it would be a very lossy chat. There'd be no logging at all. Great for privacy, assuming, of course, you've got end-to-end privacy and security. And then finally on close, we're just going to pop that connection off the client, the pool of clients, so that we don't try and send it messages when other messages come through. So let's have a look at how this works. So I'm just going to run the server from the command line, and it doesn't say anything because there was nothing to say. Now, I've recently started using Terminator as my Linux-based terminal client, and it's kind of cool because you can have lots of little windows and you can even drag them around, but I'm not going to do that this time. But I just wanted to show you. So let's imagine that the red highlight is the current window I'm looking at. So let's imagine this is chat person 1 and this one over here is chat person 2. So I'm going to telnet to localhost on port 8080. I'm not going to make any HTTP requests at the moment because if you remember from the chat system, we weren't actually talking in HTTP, we were just sending raw messages from one client to another client. So this is pure text-based over port 8080. Going to log in, and we can see down at the bottom here somebody connected. If I jump over to this side here and log in again, you can see somebody else connected. The message appears almost instantaneously in user 2's window. We've got a log here saying sending message, I am user 1. And if I then disconnect, just to prove it works both directions, if I then disconnect from this side here, we see that somebody disconnected. And if I send a message over here, you see there's no error because we're not trying to send to a connection that doesn't exist. So it takes the awesomeness of React, much easier to see what you're doing. If you compare with the original code that I was looking at, the curl one I think is probably the easiest way of doing it in the old style, where you get a known system that has robustness to make an HTTP request to a remote process, and that process that can then ensure that it runs no matter what happens to the original requester. It's probably the cleanest way of doing it. The detachment method, the second one I showed, means you've got all the code in one place. But it's not reliable. So this takes the awesomeness, or React takes the awesomeness of that. All your code is in one place, and you've got the clean object-oriented model of development. But it also uses the best of all of the old worlds of communication. And it adds WebSockets on top through Ratchet. So the React doesn't actually support the WebSockets. It's the Ratchet set of the Ratchet framework that sits on top of it that provides those. But you still face the same issues, memory overflow. I could do that in Ratchet as well. So where to from here? The loop itself, essentially because PHP isn't threaded or any of those things, it's actually still running a loop. It's just an event-based loop, and because it's not going through, because it's running within its own server, not through something like Apache, it's able to break out those events more easily, but it's still very slow because it's still processing it in a very procedural manner. So if you use something like libevent, which is a Linux-based library, it's external of PHP and Apache and all those things. If you install that, Ratchet will actually pick up the fact that it's installed automatically, and it'll stop using the PHP loop and start using libevent, which will increase the speed at which it's able to handle events significantly. When you deploy, one of the major issues with deployment is the fact that it is running on its own port. So you need to work out things like load balancing. What some people do is stick Varnish in front of it, and then depending on the kind of request that comes in, they would still all come in on port 80 or 443. Depending on the kind of request that comes in, which Varnish can detect, it'll either send it off to Apache Nginx, IIS, whatever you're using for your web serving, or to port 8080 or whatever you're running your React system on. And to solve the problem of the PHP process dying, there's a number of different tools, but the most prominent one is supervisor D, the D being for daemon, which is the suffix in most Linux space applications to say I'm running in the background and I'm doing a tool, like a web server, for example. So it's basically a supervisor to make sure that your daemons are still running. So if you configure supervisor D to make sure that React is running, then if React dies, it can spawn it straight up again. So you've still got that little bit of downtime, but it should be unnoticeable to most clients using the web service. Mathematics. So it's 35 past. I believe I have 10 minutes, so I can do some demos. Does